the point biserial correlation. What that is that um, one of the variables, one of the variables is regular, interval, or ratio scaled, but the other variable has only two possible values, like gender, female, male, so, or something like that. And how are you going to do it? It's not a scale. I mean, it's not the gender, or female, male. It's not the ranking. It's not the there's only two values. So if there are 5 people, you don't get the 5 rankings. Instead, you get only one, 2 possible values for those. So how are you going to do a correlation in that case? Like the relationship between gender and test score, relationship between whether or not you're a graduate from college, or college graduate, or not non-college graduate, something like that. How do you do that? So suppose I want to look at the relationship between gender and test score. This is how you can do. Notice I've arbitrarily coded males with 1 and females with 0. So in that case, it looks like this. And scatter plot for that would be like this. Scatter plot for that is going to be like because. Okay. This is 0, female, and this is 1, male, and you get all the scores like this. And females tend to have higher scores than males when you look at that. And so this is also very different. Scatter plot is going to be different too, compared to the previous examples. So to calculate the point biserial correlation, you can simply apply the Pearson correlation formula again, just like a experiment. You can apply the Pearson correlation formula to these data, and this is what you get. Doing so produces a correlation of R equals to minus 0.22. Okay, so slightly less than the large correlation. As gender increases, test score tends to decrease. That's what it's showing. Gender increases means going from female to male. Then test score tends to decrease. Okay. Notice this is gender increase means gender start moving from 0 to 1. Then the test score decreases. See, you see the point? So it's possible. It is possible to run a correlational testing on genders. Then we do R square to get the actual what do you call that? Coefficient of what's that? Coefficient of importance. Coefficient of determination. So it's 0.05 in this case. So we could say 5% of variability in test scores is explained by the relationship with gender. So it's a small correlation, not significant at alpha level, 5% alpha level. Remember the 0.01 and above and less than 0.09 is small. For it to be medium, it has to be at least a 0.09. So this is a small correlation. Okay. You can also use point biserial correlation to screen exam questions. For example, for any test question, you can calculate the point biserial correlation between item performance, right or wrong, and total test score. This is called item total correlation. So each question will have an item total correlation. Okay. So for example, you run this point biserial correlation on the question 5 on exam, and some people did it right and some people did it wrong, and we use 1 for correct and 0 for incorrect answer. And for this question 5, this person got it right, got it wrong, got it right, wrong, right, wrong. Okay. Then we do correlation. We ran correlation on that. Then you get R equals 0.80. So it seems like people with higher test scores tend to get them right correctly. And this is what's supposed to happen. Listen, this is correlation is close to 1, really close to 1. So that means there is significant correlation between the total test score and getting this question right or wrong. This total test score is not the, it's a, total score, total grades for the exam. So this person got 90 points for the exam. And when you just look at the question 5, he got it right. And he got 78 in total. And when you just look at the question 5, he got 0. I mean, he didn't get it right. Something like that. And what you want to see is, for this question 5, this is consistent with the subject area or topic that being tested. So anyone who can score high on overall exam, this is related, so it should be, the student, he or she should be able to get it right. So that's the idea. If there's no correlation, this question 5 might be off the topic. Maybe you didn't cover that in class. So there's no relationship between the overall performing on the subject and this question. So that's what you want to see, find out. So the item total correlation is negative for a test question. If that's the case, it means that high scores tend to do worse than low scores on a question. And that's evidence that the question is confusing, maybe. And the rule of thumb is that you want an item total correlation of 0.30 or greater, but be aware of restriction of the range.